Now.
What? It's right now.
Hmm. Do 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 do. Free tutoring for anyone who shows up. Hey. Welcome, welcome. If you're clicking on the link, it's possibly because you want free tutoring. Well, I'm here if you want it. You have some options here. You can comment in YouTube. You can comment in the back channel chat, which is a chat service that's available, that's free. And this is just for anybody who's struggling with math. If you have any concepts you need help with, I will be happy to help you. Or you can just awkwardly stare. It's up to you. I'll let some people get in, but welcome to free tutoring. Welcome to free tutoring. Do you need tutoring there, kiddo? Come here. This one wants tutoring. You say hi? Yeah, you want tutoring too? Yeah? Oh, okay. So, feel free if you guys have any questions. You're welcome to tutor. Ah! Um, I think it's open. The chat that is back channel chat is open, as well as Google Comments. But like I said, soon I'll start some actual math stuff. Help if I knew what grade you were in. If you're watching, grade you in? Comment it. Let me know so I can help you out. Are you an adult needing some math help? I know some people. Comment. Let me know what grade you're in. We can do some math for you. Help you out. Go to your room, bud. Go play in your room. Thanks, dude. And again, you're welcome to do the back channel chat. It's a free one. It's in the description. If you're curious how that works, it's there and available. But I can also add it to the comments real quick. The link. Maybe that'll help you out. Maybe not. Again, it's just free tutoring. We'll start here in a couple minutes and throw some problem ups, help you. Would help if I knew what grade you guys are in. Just saying. Because I want to, help with some math. You guys even able to comment? Is that even a thing? You know what? I wonder if I can change the description in the middle of it, because it might actually not work, and I know how to fix it though. So give me just a second, team. Hold on. Again, this is a free tutoring option for those who need it. I just need to know kind of what grade you're in. In the description is a link to a free chat if you can't chat or use chat options in YouTube. You just got to go in that description, click the link. But I'm actually going to share it in just a second. In the chat, I'm just trying to do that right now. No. My computer's being lame. Don't you like lame computers? Now my phone's being lame too. Nobody's getting into the chat. Is it broken? No. Not a broken chat. moving this? Come on, computer. Work with me here. There we go. So what I'll do is comment. This is a way to get to the back channel chat. Again, it's a free service for chatting if you can't use YouTube's. But a couple minutes, I'll start. Feel free, if you're watching, comment what grade you're in. I'll help you out. Or don't. I'll just start with some like 7th grade stuff. Or I'll just sit here and stare. Wah. Do 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 do. Free tutoring for whoever needs it. Do 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 do. Free tutoring. Yeah, no, don't worry. I'm not gonna sing. So one of the things we're doing in my class, I don't know what kind of tutoring you guys need. Again, you're welcome to comment in any of those things if you need help. But we're working on ordered pairs and what happens when you have something like this and it wants to know, hey, what's slope-intercept form? This is a really popular thing when you get into high school, 7th, 8th grade. You even see some of it in college. This is big-time algebra. There's also what happens if you're given the slope. Tells you slope is 3/4, and then it gives you a point, and you have to figure out, again, what this is. This is called slope-intercept form. One of the most used equations. Really? That's my daughter crying. I'm sorry. Hi. Hi, silly girl. Yeah. Tell me about it. So I can go over a couple of these problems. Yes, no, people watching. Would any of these help? No? Maybe? I'm done watching this guy. Forget it. Just curious. No. Again, free tutoring, but I'll attempt it. And let's see. We'll do this one. Okay, so our goal when we're given 2 points, again, we're trying to turn it into slope-intercept form, right? Our first thing is to find slope. That's m. There's an equation for that. It's so useful. It's so important to memorize. Okay, and that is y2 minus y1 over x2 minus x1. And a lot of people forget that. They really do, but it is super, super important. All right, so then your goal is to say, okay, wait, I have 2 points. You label those points. Okay, well, I want this to be my first point and this to be my second point. Keep in mind, it doesn't actually matter if you do either one. Then what you're going to do is you're going to say, okay, this x first, so this is my x of my first point, so my x1, and this is my y of my first point, so y1, and obviously this would be x2, y2. Well, this formula is what you use to find slope. It's this idea of the changes in the y and over the changes in the x. That's what they call it. You might hear it called the rate of change, slope. It's proportionality. There's all kinds of things that you'll hear from it, but really it's slope. So then I just plug it in. I'm like, okay, so 5, which is my y2, just plugging it in here, minus my y1, that's 7. So 5 take away 7, over, what's my x2? That is 2, minus my x1, which is 3. So then I get 5 take away 7 is negative 2. And then I get 2 take away 3, which is negative 1. So you end up getting negatives cancel. Negative 2 divided by negative 1 is a positive 2. So think about that a second. We'll slow it down. I plugged things into the formula, just labeled my points. Solved it. 5 take away 7, 2 take away 3. Did the math. I got a slope of 2. So what does that mean now? Well, now you know what your slope is. So I'm going to write it. Instead of putting m, I'm going to put 2. Y equals 2x plus, I don't know what my b is yet, but I can find it. And that we're going to talk about. Okay? So finding b, notice it has an x and a y. you need to find b. Okay, which means you need to get b by itself. You just want b on one side of the equation, and you want some kind of number on the other side of the equation. All right. To do that, it's just some basic algebra. But really, your goal is, you notice this x and y. Have you seen x's and y's before in this problem? Oh, wait, yeah. I used x's and y's in my formula. So if I take one of these points, we'll use 3, 7. I take it, and instead of putting x's and y's, I put the numbers that go along with it. So 7 is y, is equal to my x. So 2 times, instead of x, I put 3, plus b, right? I end up getting 2 times 3 is 6. I'm running out of space. That's okay. So I'm going to get 6 plus b equals 7, right? I subtract 6 from both sides. Again, my goal is to get b by itself, which means I need to get rid of this 6, the thing that's over there with the b. I want b on one side of the equation by itself. Take away 6 on both sides. So b is equal to 1. You just found your b. So then your actual equation is y equals 2x plus 1. And if we did it right, in theory, it'll actually work for both points. And because we found the equation for the entire slope. So we'll even try it with 2 and 5 just to show that it works. So 5 is equal to 2x. Again, that's my, oh, not x, excuse me. I'm not putting x, I'm putting 2 plus b. This is 4 plus b. We talked about our goal is to get b by itself. That's its intercept, right? Got to get rid of that. So I'm going to take away 4 on both sides. Bam. Bam. And you get b equals 1, or your sloped intercept is 1. So again, there's your slope. And I've had people ask me, why do we do that? Like, what's the point of finding that equation, finding that y equals mx plus b? And that's a great question. It's not bad to ask that. Like, it's useful because it tells us a lot of information now about our graph, right? I have 2 points, 3, 7, and 2, 5. But now that I have my equation, I can actually find every single point that exists on that line, right? Because this is just linear functions, and linear functions are literally just, if you put something in, you get something out. It's kind of the point. So for example, if I wanted x to be 1, and again, I'm making this up off the top of my head, I'm picking a number. I like number 1. If you take 1 and you plug it in where x is in your equation, it'll tell you what y is, because y is equal to whatever 2 times x plus 1 is. Okay, so I'm going to plug it in. I'm going to get y equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So when x is 1, when I input x, out comes 3. Right? I can do another one. I could say, okay, what about when I input 2? Now, we already know the answer to that, right? Because we already have our point. If my x is 2, my y should come out 5. But we'll double check. So y is equal to 2. What am I plugging in? I'm plugging in 2 plus 1. And I get 2 times 2 is 4, plus 1 is 5. Again, I have a point. So this could work in when it comes to graphs. It could work when it comes to business, right? When they're trying to figure out, cost of things, how many employees they have to pay based on the number of hours they work. This is what it all comes down to. You can even do negative numbers. Hey, I want to know what happens when I put in negative 2. Okay, so y equals 2 times negative 2 plus 1. 2 times negative 2 is negative 4. Plus 1 is negative 3. And it allows you to get all the points that consist of that graph. Because now I can take those points. I'm going to do 0. When x is 0, I know it's 1. It's my intercept. So what I'll do is I'll end up graphing it. You take that equation and you're like, okay, I want to know what that looks like on a graph. Am I having a positive slope? Am I gaining money, losing money? If you're a business, that is a terrible straight line. Oh my goodness. Right? I put it on there. 1, 2, 3, 4, 5, 6, 7. So those are those numbers of the graph. The graph. Down is negative. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Up is 1, 2, 3, 4, 5, 6, 7. This is not a perfect graph. I apologize. And this way is, you guessed it, negative. negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay, then I can take that and now I can graph it. I know 1, 3 is on the line, so 1, 3, I put a point there. 2, 5, 2, 5, right? 0, 1, I know 0, 1 is on the line. And I know negative 2, negative 3. So I'm going to go negative 2, negative 3. And I have now the points to create that is the worst straight line ever. But now that's the point, is it gives me an idea of all of those points that are on a line that now exist on that line. So that's fun. Linear functions, it's something you'll see a lot in math. If you're into that. Any questions? Anybody have any thoughts? Need any help with math? Feel free to comment. I can do questions specifically for you and help you out. Or not. Again, you are more than welcome to go to the back channel chat and comment there if you can't comment on this. Right now, we were just doing what happens if you have 2 points. I can also show you when math doesn't work. Or you tell me what grade you're in. Just you don't have to obviously names or anything. Just tell me what grade you're in. I'll help you out. We could do some double-digit multiplication. Some people struggle with that. What do I do when I have 57 times something like 26? Right? Something to keep in mind if you need help with that. Throwing it out there. Nobody? If you need help, let me know. I can help you. Oh, you know what? I actually think I know what's going on here. Hang on a second. I think I figured out the problem. Help multiplication. Okay. You got somebody else answering questions? Oh, wow. They know the answer 57 times 26. That's awesome. Did you use a calculator or did you process that out? Nice job, by the way. Anyone? Bueller? Calculator, but you could have done that. Okay. So you would have known the first step. Do you want to know a cool short? Do you know any shortcuts for multiplication? Teach people some shortcuts. Shortcuts are cool for multiplication. Like if you had something like 37 times 200, piece of paper would be useful. Person said they need a piece of paper for it. I understand. The shortcut for these, anytime something ends in 0, it's really cool. You can ignore them, but hang on them till later. So this thing's got 2 zeros. Watch this. So I'll really do 37 times 2, which is a lot faster to do. And then I remember, wait a second, I had 2 zeros, and you just add them. So 37 times 200 is 7,400. It's the 0 trick. I like that trick. So there's you that are watching. Do you need any help with any specific problems? That is a great example, partial products. That is another way to do it as well. It's a very, we'll call it an advanced way. It's actually a really good way to manipulate numbers, partial products, and understanding it that way. So breaking it apart. So you're saying 200 times 30 first, and then 200 times 7. Yep, and then add them. No, it's a great way to do it because a lot of this right here can just be done in your head. So it's a lot easier to add. That's a great mental math. I think that's awesome. Well said. So even though you're not a kid, you're an adult. Is there math you struggle with? I'm not saying I could help. I have no idea. Maybe you're a mechanical engineer or something crazy, and I can't help. I don't know. I had somebody ask me for help on Fourier transforms, and I'm going, man, I haven't done that since college. And feel free if you know somebody that needs tutoring, share the link with them. Every Monday, I'll be offering free tutoring to people. Somebody wants help on some tricky problems. Actually, give me 1 second. My screen's going to go black. Don't panic. Oh no, he's gone. No, I'm not. Don't panic. Doo-doo-doo-doo. What are you doing, computer? Work with me here. I have somebody that needs help with something specific. So, problems from a class they're in. So, I'm going to pull those up and help them out. Or try to, maybe. Okay, so you are looking for help with questions like solving inequalities. So let's do that. Let's solve some inequalities. No more black screen. No more dark screen. It's gone. Solving inequalities, I'll be honest with you, it's not something you're probably going to see a lot in life, but the concept of algebra is something that you will see a lot. And this is big. Okay. And so you're going to see something along the lines of, hey, I've got 3x minus 7 is less than or equal to, we'll go 14, right? You're going to get something along these lines. Okay, again, this is just basic algebra. You have to decide, what is my goal here? What don't I know, right? And in algebra, you're always trying to find x. So there it is, you win. No, I'm just kidding. So your goal is to find x, all right? That missing part. But to find x, you have to get it by itself. And a lot of people get really confused by this. What do you mean by itself? Right? Well, if you're by yourself, how many of you are there? Just one, right? Well, right now you have 3x's. So you're going to have to manipulate this problem to turn it into just 1x. And that's how basic algebra works. Okay? So you start with getting the term by itself. Okay? And by itself means alone on one side. This isn't alone on one side, right? Because I have this 7 in the way. So I need to get rid of that 7. How do I get rid of a negative 7? It's, well, get rid of it means 0, means gone, right? So I'm just going to add 7. It's called the inverse operation, or the opposite of that. So negative 7 plus 7 is 0. It's gone, right? I cancel it. But here's the catch, right? I can't just get rid of something and be like, oh, that was easy. It doesn't quite work that way, right? I have to get rid of it, but I have to do the same thing I did on that other side. So since I added 7 here, I have to add 7 over here. Now I was able to take away that 7. I can do that because I did the same thing on the other side. I created a balance, a scale, and that's what equations are. This is similar to an equation. Okay, so and now I'm left with, since I cancel this, I have my 3x is less than or equal to, and I add these together and I get 21. Okay, so I accomplished my first goal. Again, my first goal was to get the term by itself, 3x by itself. Remember, my ultimate goal was to get x by itself. Is x by itself yet? Well, no, it's got a 3 in the way, right? And I told you we want that to be 1, right? X by yourself, you're all alone. All by my... It's okay. So to do that, I have to do inverse operation, like I said. But I'm not going to subtract here, right? Because I can't take away 3. Because 3x take away 3 is not a thing. I can't do that because they are not like terms, okay? What I have to do is divide. okay? Because 3 times x is what this looks like. This is called the coefficient. And when it's next to a variable like this, it means multiplication. Anytime you see a number next to a variable, 5y, 3z, 4a, it doesn't matter. If they're next to each other, that means multiplication. All right? So with that in mind, I didn't cross that out, I meant to erase it. Erase! So with that in mind, you're going to divide by 3, okay? Because the opposite of multiplication, division, right? So now what is 3 divided by 3? Or 3x divided by 3? If I take 3x's, right? So 3x's, I have an x here, an x here, and an x here, and I divide them into groups, 3 groups, right? I'm going to get how many in each group? Well, 1, right? So 3x divided by 3 is just 1x, right? But I'm not going to put 1x. That would be silly. You wouldn't do that, right? If I had a friend named Jason who walked into the room, I wouldn't say, "Hey, look, there's one Jason." Well, no, I would just say, "Hey, look, there's Jason." Now, if there were 3 Jasons, obviously I'd probably be confused, but I would say, "Hey, there's 3 Jasons." Same idea with this. 3 x's, right? X. But you can't forget, what did I do on this side? I divided by 3. So whatever I do on one side, I have to do on the other. So I divide this side by 3. So whatever this answer is, 21 divided by 3, which is 7. I now found my answer. X, the answer to X, is every single number, that's my daughter, every single number less than or equal to 7. So 6 would work, 7 would work, 5 would work, 4 would work, 3, 2, 1, zeros, negatives, all of those would work. So, something to keep in mind. Fun fact. All right, now there's a catch with this. Okay, and inequalities, people get really confused for this one concept, and I will tell you, most people forget this. Yeah, ratios and proportions are way big, especially because I teach 7th and 8th grade, and I appreciate the view. You're totally awesome. You deserve a raise. The biggest thing about ratios and proportions that I love is it leads so well into 8th grade, which digs into slope, right? Like I never until I taught both grades, I didn't realize how good that correlation was. Because it's absolutely a huge topic, especially in testing. But I appreciate the view, and I hope feel free to share this with students if you know any kids that need tutoring. I know a lot of my kids did. I think 3 of the kids watching are some of my students right now. Um, but I appreciate you showing up. And if ever you need me to make a video, like if your kids are into me with a goofy puppet, and you need a topic, let me know, and I will attempt to make one. So with inequalities, back to that. The hold on, reading a chat. And I'll definitely teach ratios and portions. I'll help with that. But a big thing about inequalities, something that you guys might see, is something along these lines. Okay, and we'll go, man, oh man, we'll go 13. Okay, if you see something like this, okay, this is where most people, most adults, I mean, honestly, they forget this part of inequalities, and it's one of the most important. Okay, your process is still the exact same, right? Your goal is to get this term by itself, and then eventually the x all by itself to solve it. Okay, so what I'm going to do is subtract 3 from both sides to get that term by itself. I know. I'm going to get 13 take away 3 is 10. Okay, now here's where the trick comes in. And here's where people get confuzzled. Right? They go to get x by itself and they divide, which is exactly what you need to do, divide by this number. You're always just going to divide by the number next to x. Always. Is -5. All right? And I'm also going to divide this side by -5, right? But here's the catch. And here's the exception with inequalities. Anytime you multiply or divide, but specifically we'll just say divide right now, if you divide by a negative number, you have to flip this sign. which means it's no longer greater than, it's also less than. So now 10 take away 5 is, or sorry, 10 divided by negative 5 is negative 2. Now notice I flipped the sign. The sign goes the opposite direction, right? Sign goes the opposite direction because I had to flip it based on dividing by a negative. That's a big exception with inequalities. If you can remember that, you remember things that 99% of people forget when it comes to inequalities. See, my daughter agrees. Okay? So that's big too. So any other math topic helps. I know somebody mentioned the ratios and proportions. Those are big as well. We can talk ratios and proportions if somebody needs help. How to deal with ratios and proportions. What's really cool is math builds on itself. So if you have this understanding of fractions, something like 3 over 2, right? Proportions is this idea that it follows a rule, it's the same, right? Picture it this way. If I were to tell you that I have the best recipe in the world for lemonade, and I told you that my grandma gave me this recipe, it's pretty straightforward. It's 3 cups of sugar water and for every 2 lemons, right? If I told you, hey, 3 cups of sugar water, 2 lemons makes the best lemonade ever, right? You're thinking, well, that's kind of, are you sure? I'm telling you, yeah, it's true. So that's a ratio of 3 to 2. But why would we use that? What's the point of it? Well, the thing is, this may make 1 cup of lemonade, right? And if this only makes 1 cup of lemonade, but you have 10 friends coming over, right? Using this ratio or this proportion can help you then figure out how to adjust your recipe, right? It's kind of a real life application of it. So I know that, hey, this right here makes 1 cup and I need to figure out how to make 10. You would just do the math. So I'll show you how that works. Okay. This is the basics of it. So first goal is you need what's called a unit rate. This right here is your best friend when it comes to proportions, actually slope later, all of that. The unit rate, fantastic. Unit rate breaks it down. It just means, what is she eating?
It's a baby bar.
Nice. Unit meaning 1, right? Your goal is to turn one of these into 1. What do I mean by that? Well, it is a lot easier to work with the number 1 than it is to work with 2s and 3s, so on and so forth. So your first goal is always to turn something into a unit rate. That helps so much. Okay? So I'm going to divide. How do I do that? Pretty straightforward. I'm going to start with my denominator, right? How do I turn a 2 into a 1? Well, I could subtract 1, but it doesn't really work that way. You always are going to divide in this case. I'm going to divide by 2. 2 divided by 2 is 1. It's perfect. So now I'm going to divide this side by, the denominator by 2. Or sorry, excuse me, the numerator by 2. So 3 divided by 2, well, we'll call it 3 halves right now. I know that looks really silly. But the point to this is just to show you how this works. So I've got 3 halves over 1. I have a unit rate where one of my numbers, my numerator or my denominator, is a 1. Okay? Now I can figure out how many cups of water I need if I have 10 lemons, right? Pretty straightforward. Well, if I have 10 lemons, how much water do I need to make it taste the same? It's pretty straightforward. I go from 1 to 10. I multiply by 10 to get there. So I multiply this by 10. Notice how easy it is to deal with a fraction when the denominator is 1, because then you can just multiply by easy numbers. Follow me? Hope that's making sense. That's with ratios and proportions. That's one way you can use it. They also graph ratios and proportions. They'll also tell you, like, hey, you have a recipe that calls for 1/2 cup of flour, and you've got maybe a third a cup of sugar and a cup of oats. Makes like the best oatmeal cookies, and it wants, that's terrible handwriting. Oh my goodness. And it wants to know, hey, what happens though? I have a cup of oats, cool, But what happens if I only have a half a cup of sugar? I actually can't use a third a cup, right? Like I don't have the right measuring cup. How can I make it taste the same? And you would just use ratios or proportions to do that. Here's how, right? You'd say, okay, well, I know that 1/3 cup of sugar, call it sugar, 1/3 sugar is the same as 1 cup of oat, right? I know this, right? And I want to figure out, okay, well, this is a ratio where one of them is 1, right? The problem is I'm dealing with sugar, so I have to turn that into 1 first, which is pretty easy, right? How do I turn anything into 1? I divide it by itself. So I'm going to divide this by 1/3. Dividing by 1/3 is the same as multiplying by 3/1, right? Keep change reciprocal. Gotta love division of fractions. So I'll multiply this by 3/1. So it's for 1 cup of sugar. I need 3 cups of oats, right? But here's the thing, I told you that I only had a half a cup of oats, right? I only had a measuring cup that's a half. So what do I do now? Well, that's okay, because I know that 1 cup of sugar, right, gives me 3 cups of oats. I figure, well, how many oats do I need for this? Well, straightforward. I know that if I only have a half a cup, I'm going to turn this into half a cup. So by multiplying by a half, right, that's the benefit of having 1. And I multiply this by a half. You end up getting 3/2. So how much do you need cup of oats? Well, you would need 1 1/2 cup in order to, or sorry, 1 1/3 cup, which gets, complicated, but that would help you how many oats. So that's ratios and proportions. They use that a lot when it comes to algebra. But your big thing, your big takeaway, here's a secret to math. Every single math ever really only uses addition, subtraction, multiplication, and division. Like think about every problem I just did. I had addition in there somewhere, I had subtraction in there somewhere, I had multiplication somewhere, division, so on and so forth. Same idea, that's every single math concept. If you can think of one that doesn't have those, I'd be excited, because I'm pretty sure they do. So, anybody else struggling with a concept, or you can give me a grade that you're in, and I'll help you problem solve through some things. No, you guys want to learn? Somebody mentioned partial products. Check this out. So, hi, welcome to live tutoring. That is terrible 4. Oh my goodness. You guys ever seen partial product multiplication? This gets crazy. If you need help with the topic, by the way, you're more than welcome to comment. Like if you're struggling with, for example, linear functions. I know linear functions was something you're struggling with. Do I enjoy doing this? Sure. I like math. Like I'm one of those weird people, that like even if I sat here an hour by myself, I would entertain myself by doing math problems. True story. Right? I would just create some fun problems to try to solve. Does this seem enjoyable? Coming to free tutoring? Like how often is tutoring free? Does that like ever happen? It's crazy. It's crazy. Plus, it's entertaining to watch my daughter try to be distracted and she's making noise over there. But anyway, here's partial products. You guys ever seen something like this? If ever you're multiplying and you got 2 digits, and rather than doing the whole long process that you learned, I'm sure we have to do placeholder zeros and you end up doing all of this stuff, right? And then add it together. You're like, oh, that's so much math. There's actually a different method that is called partial products. And here's how it will work. So this number 37, right, is broken up into 30 right, and 7. If that makes 30 and 7. It's the partial parts of them, or the place values of them, right? If this was 237, then this would also be 200 plus 30 plus 7. It's also like the expanded form of a number, okay? So what's really cool is I can now take 42 and multiply it by both of those, which is a little bit easier math. This is called partial products. It's a little bit easier math because now I'm just multiplying with zeros. And when you multiply with zeros, it's really cool. You can just take this number, you can shift it over and place it like this. Right? This is the rule of zeros. That's really cool. Right? And instead, I'll bring this 0 down. I just do this math, and it's super easy. 2 times 3 is 6. 4 times 3 is 12. Right? That's 1,260. Then I do this part, 42 times 7. That's 4. 1. That's 29. Right? Now I just take those two numbers, 1260 and 294, and I add them together. Some people think, hey, that seems like a similar process. Yeah, Addie, I know. And it is. You'll notice get the same answer. You'll notice it's the same. It really is because all I did was look, there's 1260. There's 294. So what happened? What did I do? Well, partial products breaks it down so your math doesn't get as confusing. Some people don't like to look at it this way. Some people like to do one problem at a time and add. Totally an option. That's called partial products. It works for, I feel like it's better for bigger numbers, right? When you get into 3,765 times 2,898. Like, I feel like it's a lot easier to do that, partial products with this type of problem, than it is with other ones. Because then this one, if you do it out, you're going to have like placeholder 0, and then 2 placeholder zeros, and then 3 placeholder zeros, and it just gets crazy. Partial products makes it a little bit easier to break down because I know I'm going to do 3,765 times 8. That's the ones place. I'm going to do 3,765 times 90. That's the tens place. But remember, I shifted over, right? And this is one way to do it. I do 3,765 times 800, but again, I shifted over, right? Well, it seems like more work. It's not. And then I do 3,765 times 2,000, but again, I just shifted over. Right, so I've got 0, 4. 48 plus 4 is 52. I don't know. 2, 5. 7 times 8 is 56. Add 5. 61. 24 is 30. So there's my first section, right? My first number that I'll later have to add. Right, bring my 0 down, and you have to do the same thing. 5 times 4. Or sorry, 5 times 9 is 45. 6 times 9 is 54. Plus 4 is... Wait. Math! Oh! See, teachers make mistakes too. Don't let them tell you they don't. Especially when they're trying to go fast. Yeah, Dad makes mistakes too, huh? That's 8 and 5, because 6 times 9 is 54, plus 4 is 58. 7 times 9 is 63, plus 5 is 68. 9 times 3 is 27, plus 6 is 33, so I got another number here, and so on and so forth. And you just do all those with the zeros, you add them up. It's a lot easier than doing the chaos of trying to follow along. I guess the easiest way would actually be a calculator. Calculators are the best. Just saying. And we're in a world now where calculators are in our pockets. You guys ever notice that? Like when I was a kid, sure, we had calculators, don't get me wrong, but I didn't carry one around my pocket all the time. Now my phone is my pocket. Right? Kind of cool. Anybody struggling with math? Need some help? We got about 15 minutes left of free tutoring this week. If you need some help, let me know. I can help you out. Or not. Oh, you need help? I don't want to talk. Word problems for linear functions. Yeah, we can. I gotta look one up though. I can't make one up off the top of my head. You cool with that? Give me just a second. I will delete my display just so I can pull up a computer screen here and search linear functions word problems. Ooh, this sounds fun. I'm excited. Is it weird that I'm excited? I gotta find one. If you have one, feel free to put it in the chat, and I will do it for you. It's extremely loud, babe. I don't know. It's all good. Let's see. Word problems. Here we go. So you're thinking something like Seth's father is thinking of buying his son a 6-month movie pass for $40. With the pass, matinees cost $1. If matinees normally are $3.50 each, how many times must Seth attend in order for it to benefit his father to buy a pass? Are you looking for something like that? Or something like a plumber charges $25 for service calls plus $50 per hour of service. Write an equation in slope intercept form for the cost C after 8 hours of service. The total cost for 8 hours of work, 10 hours of work. Here, let me pull it up on the screen. These are possible. So these are word problems that involve linear functions. So if you see a number that you're like, oh yeah, do that number, help me with that kind, I'm more than happy to. These are slope intercept form word problems. So if you want the water level one, Seth's father, babysitting costs, plumber charges, all of them. One. All right, let's look at one. All right, I'm going to break down word problems. How I normally break down word problems, I always read it first. So suppose that by the way, I hate when people do like that whole underlining thing and do all that. I don't normally do that. I do something a little bit different. So just follow along here. So suppose the water level of a river is 34 feet, and that is receding at a rate of 0.5 foot per day. Write an equation of the water level L after D days. And how many days will the water level be 26 feet? So I'm noticing that this thing is asking 2 questions. That's what I would do next. I always go and find what it's asking me to do. So this thing wants me, I'm going to circle it. So again, I don't underline all the important information, do all that. I want to underline, what is this thing asking me to do? It's asking me to write an equation, right? That's the big thing. And then it wants to know in how many days will the water level be 26 feet. So there's 2 things I need to find in this, right? So I'll do that. Let's do this first. I need some more space to work, so I'm going to cheat. Really fun tool, if you don't know how to use it on your computer, is the Snipping Tool. It'll actually take a copy of your screen and allow you to paste it into other parts. So I did that right there. So now I can see it. It's called the Snipping Tool. Fun fact. Go eat. Enjoy food. All right, so let's take a look at one. So I know that it wants me to use letters. That's one big thing you have to know about word problems, especially with these, is it gives you the letters you want to work with. A lot of people are tempted to use Y and X and all of that. It's telling me use L and use D. Okay? So what do I know? Well, I know the water level of the river is 34 feet. Okay, so my L is 34 feet. Hello. Okay? I know that it is receding at a rate of 0.5 foot per day. So the next time when you go to write these, you want to look for these things like per or rate or how much money they make every day. Things like that. Look for words like per, every. Those tell you which numbers go with the variables. Okay, that's really important. So you know that this is 0.5, which is a half. So I'm going to use half. Hope you're okay with that. A half each day. Okay, each meaning multiply. You with me on that? So half times D. This is telling me this. This is the only reason I'm using this because it literally says it. 0.5 per day. Okay, that's what it's dropping. All right. Well, I know that the river itself is 34 feet. Okay, so it's a simple concept to think, well, what does that look like? Well, I know that it's at 34 feet consistently. And I'll talk about what I'm doing here in a second, so bear with me. And so what is this problem based on? It's based on the level of the land. Well, it told me that you need to use level. So I broke this down in a weird way, but I'm going to, just so I can explain it. So just watch. So this thing is asking me, what's the water level going to be? Right? So I know that in my slope intercept form, right, this thing, I know that I'm looking for my y. The y is the equals thing. It's the what is the water level? That's my L. You always look for, again, what's it asking you to find? It's asking you to find water level. So that's always going to be the part that's equals. That's the part that's on your left side. What is the water level equal to? All right, so people ask, well, where did you get 34, like plus 34? Why is that there? Because that's my starting point, right? It's telling me that the water level was at 34 feet, right? So that's why I'm doing plus 34, because at 0 days, if this was 0, like if nothing passed, right, I'm at 34 feet. Okay, well, wait, now a day has passed. Well, now it's dropping half a foot. Right now it's dropping 2 feet, so on and so forth. This is just your equation now of what's happening to that water. Really? Wow. Sorry, kids these days. So then it's now, I have my equation. This right here helps me find everything now because I say, okay, in how many days will the water level be 26 feet? Well, that's pretty straightforward. I need to know what D is, right? It's asking me how many days will the water level be 26 feet? Okay, well, water level, 26 feet. When the water level is 26 feet. That's my L, right? So when L is 26 feet, it wants to know how many days that took. So notice I plugged in 26 for L, and now you would just solve for D, right? Subtract 34 from both sides, so on and so forth. Do the math. I hope that makes sense. I hope that makes sense. And again, this is um, functions. You might actually see this one, just so you know, like, and this is not going to change it too much, but the and I want you to think about what I'm doing for just a second and think about why I'm doing it. They might have you write it in this form, where it's 34 take away 1 half D. Now, why do you think they would do that? Keep in mind, you would still end up getting the same answer through problem solving, but they have you write it like that because the water is receding, right? So it's a takeaway problem. You might see it like that as well, right? Because you start at 34 feet, like we said, that's the water level, and then each day they're taking away a half a foot. It's another way you might look at it. We'll look at the second problem too, just for practice, because I think this is awesome that you're asking questions and seeking help. You're going to be better at math than every person you know because you're trying to get help. Let's pull up another problem. You're welcome. Of course. All right, so we're looking at Seth's father now. Here we go. And again, same thing you're going to do every time. You're going to look like, okay, what is this problem even wanting me to find? Because that's the biggest part of it. What's it asking me to find? So Seth's father is thinking of buying his son a 6-month movie pass, okay, for $40. With the pass, matinees cost $1. If matinees are normally $3.50 each, how many times must Seth attend in order for it to benefit his father to buy passes? Whew! Seems complicated, but it's not. Again, go straight to what does this thing want me to find? What is my goal? Well, it wants to know how many times must Seth attend in order for it to benefit his father, right? So now we're going to look for some things. If I'm knowing how many times I must attend, I need to know what it costs to attend, right? I need to know what original cost is. So you're always going to look, what was my original cost? Well, it's $40 for your original cost. And now this time it doesn't use variables. Notice it doesn't give you specific variables, so you can use X and Y, right? Remember, you want it in this form. So I'm going to use 40. 40 is my, what would you call it, your B. That's my starting point, right? You always look for your starting point. 40. Okay? I am going to look for my Y, which in this case, my Y is probably going to be cost. What is it, Addie? Crazy. I know. Okay, but it's not going to be 40x, and here's why. The next part you look for is your variable term, right? Remember how I told you look for words like per and each and for every. Right? That's what you're going to look for. So I'm going to look in here. I'm going to say, okay, if the past matinees cost $1, but if matinees are normally $3.50 each, how many times must Seth attend in order for it to benefit? Well, wait a second. 350 each. That's the normal cost, right? So I want to know 350x, that's my cost, right? I want to know when does this part, 350 each, equal my 40 bucks? Like how many times do I have to go? I'll change this up a little bit here. Check this out. My y is 40, like I said, right? I want to know when is it equal to 40? All right, so this wants to know, wants to know, okay, this is my x. Are you still with me? Got $3.50 each, right? So this is how many times I buy a ticket. If I buy one ticket normally, two tickets normally, blah, blah, blah. Hi, Adeline. My daughter's waving at me. Hi. Um, Hold on, I lost my thought of train.
$40 each ticket each for that thing.
Oh, thanks, babe. So if the whole thing is 40 bucks, right? That's what my y was. So now I have to figure out when does this benefit itself? When is x going to be 40? Isn't that what it's asking? How many times must you attend in order for it to benefit to buy a pass? Right? You with me on that? There's no b on this one, and you could, because b would be kind of 0 because it doesn't affect it. Just wants to know when does this equal 40? That's a tricky problem. They're trying to make it complicated because a lot of times the b is 0. But the big thing about solving word problems, and just here's my advice, and this is what I tell my students all the time. Figure out what are you trying to find. From there, figure out your original price or the thing that doesn't change, your constant. Figure out what that is, and then figure out your variable term. I'll give you another example. Last one, and see if it'll help. We'll talk about that, and hopefully that process itself will help. We'll look at the plumber. And every single word problem can follow those same patterns, those same rules, because I know this is tricky, and I appreciate your perseverance here. Check it out. I'm gonna do the same thing. Okay. A plumber charges $25 for a service call, plus $50 per hour of service. Write an equation in slope-intercept form for the cost C after H hours of service. What will be the total cost for 8 hours of work, 10 hours of work, so on and so forth. So this wants me to, again, I'm going to look to see what is it asking me to do. Well, it wants me to write an equation in slope-intercept form, but it gives me my variables this time. So cost C after H hours of service.
Sweetheart. That's probably not a smart choice.
So I'm looking in for y equals mx plus b. But the difference is I'm not using y and x, I'm using c, right? So c is equal to whatever my slope is, h plus b. That's just the form it wants it in. So again, I know what I'm looking for. I'm looking for an equation. So I need to go in and find my constant. What is the thing that is consistent? Okay, you got a plumber charges $25 for a service call plus $50 per hour. Which one is consistent? Which one doesn't change? Well, that's a $25, right? So that's my B. That part doesn't change. Okay, the next part I'm going to look for is my variable term, right? Again, looking for words like per, each, every, right? Do you see those words? Right here, per, right? So that's $50 per hour or per H. If you notice, you ended up finding your equation by just following those rules. What am I trying to find? What's my constant, right? What's the variable term with per, each, every? Now you have this, you can solve this next part. So what will be the total cost for 8 hours of work? Instead of H, I'll put 8. 50 times 8 plus 25. Well, 50 times 8 is 400, plus 25 is 425. So that tells you now how much will it cost you if you hire a plumber for 8 hours? $425. So on, so forth. The process is the same every single time solving word problems. Did that help? Yes? No? Maybe? Yeah, was that helpful? If not, it's okay. You can be honest with me, and then I'll try to pull up some problems next time, and we can dig into it more next time in tutoring on Monday. Um, but again, what am I trying to find? Look for my constant, what doesn't change, and then look for the per every each. I'm glad it was helpful. That's the end of tutoring for today. I appreciate you guys showing up again every Monday, 2:30 to 3:30. I'm here. If you guys ever need math help, I'll do the best I can to help you. And if I don't, I'm sorry, but at least you're trying. You'll get it. See you later.